Okay, so today we're going to learn about matrices. What is a matrix? So it's not the movie of the Matrix. This is the formal definition. It's a rectangular array of variables. So you can see like right over here, this is a matrix. It has 6 entries in it. Some of those are numbers, some of those are variables. They're horizontal and vertical rows and columns, and that's what a matrix is. And you might say, well, why are we using this? We're not going to really get to the point this week of why we're using this. There's a couple reasons. So one way is to solve systems. So another way of solving a system, like we've learned elimination substitution, you can use matrices to do that. We're not going to get to that this week. Um, Big picture, a lot of like encryption on the internet. So like when you enter your credit card number in to buy something off Amazon, it doesn't just translate and go through the internet to Amazon. It actually goes through kind of an encryption process, and typically they use matrices in these encryption processes. So it takes a large amount of data sometimes and can kind of send it and encrypt it so that it's a very safe way to send data. These are entries, so those are the 6 entries in that particular matrix. You name a matrix by row and column. So here's what we mean by that. So when we name a matrix, so like this is the row and this is the column. So row by column, R by C, kind of like a 2 by 4, R by C, row by column. So that's not an X there, that's a word that is by, 2 by 3. So to 2 rows, 3 vertical columns. So you can see there are 2 horizontal rows, there are 3 vertical columns there. So that's a 2 by 3 matrix. It has 6 entries in there. Um, Adding these is piece of cake, probably. It's not that bad. Let's look at what the dimensions of this matrix are first. So this would be, let's see, this is a 1, 2, 3. This is a 4 by 2 vertical column, 4 by 2 matrix. And this also is a 4 by 2 matrix. So to add 2 matrices, they have to be really the same size. So what we're going to have is we're going to have 2 matrices that add the same size. The dimensions of the answer are also going to be the same size. So it's going to be 4 by 2. So I've just put kind of spots in there where we're going to actually fill that in and get that. Okay. So to get, say, the top left here. So the top left is 2 plus 1. There's a plus there. So 2 plus 1 is 3. The top right term, 3 plus 5 is 8. This is really easy to do, right? 4, that kind of the left-hand column, the second term down, 4 and -3 adds up to 1. -6 plus 4 is -2. Okay, this would be kind of interesting. So this one are variables. So this would be A plus F is that entry. And then B plus B, or 2B, when you add up the 2B's there. The bottom left-hand term is like 3 plus C, or C plus 3. Those don't really add nicely together. And then finally D plus E. So that's the resulting matrix. You're just going to add the dimensions, or add each corresponding entrance. And this is important. Sometimes you get 2 matrices. These two had the same exact dimensions. Row by column were the same, so we can add them, no problem. The resulting matrix will also be a 4 by 2. However, sometimes the dimensions don't match. If that's the case, what do you write? You say impossible. You cannot add those 2 matrices up. Okay, let's try this one. So this is going to be a 2 by 2 as far as rows and column. This has 2 horizontal rows, so 2 by 1 vertical column. So can I add these 2 matrices up? Absolutely not. Impossible. So let's go a little bit further. I'm not sure if the book even, your book even has any example problems of this, but I want you to know how to do this, and it's really not that difficult. So let's find 2A. So 2A would be 2 times matrix A. Typically with a matrix, we name them by a capital letter. So 1, 2, 3, 4, plus 3B. So 3 times B, 5, -1, -3, and 0. So I'm going to do the scalar multiplication first. So it's kind of like it just distributes to each term, really. I mean, that's exactly how you think it might kind of work. So 2 times the matrix 1, 2, 3, 4 would be 2, 4, 6, and 8. And 3 times that matrix would be 15, -3, -9, and 0. Doesn't really change any of the dimensions or anything. It's still a 2 by 2. It's just got, you just distributed the 3 and the 2 there. So now we're going to add up, like the different spots here. So like the top left and the top left. So this resulting matrix 2 plus 15 is 17. The top right is 4 and -3, so that would be 1. 6 and -9 is -3. And 8 plus 0 is 8. And so again, we added a 2 by 2 plus a 2 by 2. We've got a 2 by 2. And that's how you do that. By the way, you can also do this in your calculator. Not necessarily something I want you to do for homework. I want you to do homework by hand, check them in the back of the book. But I want you to know you can do this. So there's a couple ways to get to matrix. One way is to go matrix or menu and go to matrix. And the first one is create. Your side looks like a 2 by 2 there. So I can type in 2, 4, 6, and 8 plus. I'm going to show you another way to enter a matrix. If you hit the template key, if you scroll down to here, do you see that's a 2 by 2, that's a 1 by 2, 2 by 1. That one's customizable matrix, but this one happens to be a 2 by 2, so I'm going to click that one. This would be 15, -3, -9, and 0. And we should get the same answer, 17, -3, 1, and 8. You got it. So the calculator can handle matrices. There's a couple questions on there. We'll learn about multiplying where you really need to do it by hand, or you won't be able to get the ACT questions right necessarily. This is not on the SAT at all, but the ACT does have some matrices. It's really kind of what I prepare. It's kind of like introduction to matrices this week. We're not going to go that much into it, but that is how you do matrices. Another thing about matrices, they must have the same dimensions to be equal. So like this one would be a 3 by 1 because I have 3 horizontal rows, 1 vertical column. This is a 3 by 1. Those are equal matrices because of the equal sign, and they look equal. These might look equal. They have the same numbers in them. However, this one is what? I guess this would be a 1 by 4, 1 row, 4 vertical columns. Those two are not equal, right? Because even though they have the same numbers, it's not in the same type of display. You need equal matrices in order to add or subtract. So this one, I do want to, you see there's an example of the book of something like this, and I want you to be able to do, first of all, subtraction, and also kind of a more difficult one like this. So for this one, you have this first matrix, that 2, 0, -3, 5, -1, and 2. And you're going to subtract another matrix from that, and you're going to get this other matrix, 5, -4, 3, 0, 7, -2. The dimensions of this matrix, by the way, are a 2 by 3. This one is a 2 by 3. So one thing we know about this matrix that we don't know yet is it's definitely going to be a 2. I'm just kind of writing the entries there, a 2 by 3 matrix there. Okay, so just so we can kind of set up some equations or think it through, I'm just going to call it like, instead of calling each one x there, I'm going to call it like A, B, C, D, E, F. We're just going to figure out what A, B, C, D, E, F are here and kind of like, solve this problem. It's not really that difficult, but once you see it. So this is 2 minus A would equal that one. So if you want it off to the side, you could go like 2 minus A equals 5. Now, some of you can just kind of think that through. You'd be like, oh, 2 minus -3 is 5. But for the rest of us, we just have to kind of like solve that like an equation, like subtract 2. And you get -A equals 3. And then divide by -1, divide by -1, you get A equals -3. So I know that x that's -3 right there as the top left-hand term. And again, you can just keep setting up more equations. So like for the next equation, it would be 0 minus b equals -4. 0 minus b equals -4. So negative b equals -4. So b equals 4. So that one is 4. And let's try to do some of these in our head. So -3 minus c is 3. -3 minus -3, right? -3 is like +3 is, wait, sorry, -6, right? Yeah, do it in our heads and then we would mess up. Let's just double check that one. So it'd be -3 minus c equals 3. So negative c equals 6. So c equals -6. Yeah, so that is right, -6. Set up the next one. 5 minus d is 0. 5 minus 5 is 0. That's easy. -1 minus e is 7. So -1 minus -8 is like +8, which is +7. And 2 minus f is -2. 2 minus 4 is -2. So pretty soon you figure out the matrix, which is really what we're trying to find. The matrix X would be this matrix right there. So I think that's really all you need for homework. I think it's one of your easier homeworks of the year. Um, I think you'll do just fine on it, but we will have a Q&A at 11 o'clock tomorrow, I believe, or the next day. Yeah. So if you want to come to that, if you have any questions on homework before you take your quiz. Thanks. Have a good day.